Hello, today is I'm going to make a video about the practice exam 3. I'm going to go through all the problems, hopefully help you understand each problem better and you do better on the exam. Okay. All right, let's get started. So number one, we want to simplify this. If I was you, the first thing I do for 1a is that I'm going to bring the two radical into one single radical, right? Because they have the same index, I'm allowed to do that. And because I see 298, they both even number, I can simplify them. I see m to the fifth on the top and then m to the first on the bottom. I can also simplify them. So first thing first, we're going to bring it under one radical. So it's going to be 200, a little bit, m to the fifth divided by 98m. All right, now simplify factor by factor. Let's simplify the number first. So 280, 98. Both divided by 2, right? So 200 divided by 2 is 100. And then 98 divided by 2 is 47. And I don't think you can simplify more in terms of like common factor. How about m to the fifth and m to the first? There's a rule, right? There's a rule. Let me remind you the rule. If I have a to the m divided by a to the n is equal a to the m minus n. So it's going to be 5 minus 1 be m to the 4. And we're going to write m to the 4 on the numerator because m to the fifth is bigger than m to the first, and then it's on the top. So the final result will be on the top, right? Now you can simplify each of those, right? You can break it into separate square roots. So say somebody gonna do square root of 100 times square root of m to the 4 divided by square root of 47. Well, I'm not gonna do that. It just takes too much time. I'm just go ahead and simplify factor by factor, right? So square root of 100 is 10. Oops, I'm sorry. 98 divided by 2 is 49. I don't remember what I said, but I wrote wrong. So square root of 49 is 7. Right, 7. So square root of m to the 4 is, use the put method, is going to be m squared. Right? And that'll be your final answer. Part B, again, I'm going to bring this under one cube root because I see that I can simplify 54 with the 2 and y squared and then y to the fifth, right? And the reason you'll be able to bring it under one root because they have the same index. It had to have the same index, right? Not every time you can be able to simplify. So cube root of 54 y squared z squared over 2y to the fifth. All right, 54 divided by 2 is, 2, 14 divided by 2 is 27. And then y squared and y to the fifth is simplified as y cubed. Y cubed is going to be in the bottom. And then z squared. Now, simplify factor by factor. What is the cube root of 27? 3, right? What is the cube root of y cubed? Well, y. However, we cannot take the cube root of z squared because the exponent is smaller than the index. You cannot simplify, right? So just rewrite it as is, right? So cube root of z squared. So the z term is still under the cube root. Um, 2a, there are two ways of doing this. One is that you can bring under one root and then simplify it before. What I'm going to do is I'm going to rationalize it first and then simplify it later. Okay. Now, what's rationalize the denominator mean? That means I don't want any more radical in the denominator, right? So here is the square root. There's an index 2 there, but we don't write it, but we understood it's the index 2 there. You have one of them. How many more do you need in order to get rid of the square root? one more, right? So I need one more square root of 6. I need one more square root of 6. So square root of 6, if you multiply square root of 6 in the bottom, you have to do the same thing to the top, because this expression is not 1. Okay, so now you can go ahead and multiply across. So square root of 36 times square root of 36 is square root of, I'm sorry, square root of 6 times square root of 6 is square root of 36. Square root of 10 times square root of 6 is square root of 60. Square root of 36 is 6. Square root of 60, you can break it down a bit more, right? So let's see, over scrap paper here, 60 is 2 times 30. 30 is 2 times 50, so 4 times, so here you can say 4 times 15, right? So this one, you can break it down into, move it up, back up here, into square root of 4 times 15. Square root of 4 is 2. Or you know, let me do one more step. I can break it into separate roots. So square root of 4 times square root of 15 over 6. Square root of 4 is 2. Square root of 15 is square root of 15 over 6. Simplify the 2 with the 6. So 6 goes into 6 goes to 3 times, right? So it's gonna be 1. Well, 1 time root 15 is root 15. So root 15 over 6. That'll be your final answer. We'll move it down here so I can box it up. All right, B, again, whatever you missing, you just multiply by how many more do you need, right? So here is, we have cube root. Now, we cannot simplify the 3 here and the 3 here. They're two different things. One of them is under the cube root. So they are to wear different hats. You cannot simplify them, right? We have cube root. So now we have 1 here. We have 1 cube root here. How many more do we need to get rid of the cube root? Well, we need 2 more, right? Because we need what? We need to multiply with cube root of 3x squared times cube root of 3x squared. But I'm not gonna write like that. I'm going to write it like this. Cube root of 3x square. And of course, I'll do the same things to the bottom. I'm sorry, to the top, cube root of 3x square. And now all I do have, I'm gonna multiply across. So let's take care of the denominator first. So the denominator is, I have cube root of 3x square cube, right? Well, the cube and the cube root cancel, so it's just 3x squared on the top and the bottom. Because this guy and this guy cancel, right? Now the top, let me expand a little bit. The top, the 3 times, the 3 outside, I also keep it like that. So 3 times cube root of 3x square is, oh, by the way, if don't write this down, this right here is the same thing as cube root of 3x squared, all of that square, okay? It's a 2 different ways of writing the same thing, all right? Because sometimes I write a little bit different. All right, so distribute the power. So 3 squared is 9. 3 squared is 9. And then x squared is x to the 4. Can you take the, so let me write down here. So the 3 times, can you take the cube root of 9? I hope not, right? Because in order to cube root, it has to be at least what, 27, right? The 3 times 3 times 3 is 27. So cube root of 27 is 3, but cube root of 9 is nothing. So you will leave it like that. Actually, I'm going to show you a method that I showed you before. I'm going to split this right here into a perfect cube and not a perfect cube. Do you guys remember that? So the perfect cube on the left and not a perfect cube on the right. So 9 is not perfect, so I'm going to put it to the right. I'm going to put in the second one. What about x to the 4? You can split it into one of them, be able to take the cube. So x cubed and x to the first, right? I can get rid of the 3, right? It's cancel. It's cancel just 1. Cube root of x cubed is x. Well, cube root of 9x. This is cube root of 9x. And then the bottom, I have x squared. I can simplify further. I can simplify the x to the first with x squared. That's leave me 1x in the denominator, right? And the top is cube root of 9x. And again, please do not simplify this x with this x in the bottom. Okay, I color them 2 different colors because one of them is under the square root, the other one is not. They wear a different hat. Cannot simplify them. Okay. And that'll be your final answer. Okay. Part C. Again, rationalize the denominator mean I do not want any more radical in the denominator. If you have 2 terms that connect to each other by a plus or minus, then in order to rationalize the denominator, you multiply it by the conjugate of the denominator. Okay, so please remember the conjugate of the denominator. On the quiz, I see some people multiply the conjugate of the numerator. So that means I'm going to multiply the top and bottom by 1 plus square root of 5 over 1 plus square root of 5. And then I distribute and FOIL, whatever I need. Right. On the top, I'm going to leave it like that. I'm not going to distribute the A because I may be able to simplify it later. The bottom, I don't know if you remember, I show you how to use these difference of square, difference of 2 square to simplify the bottom without doing foiling, right? So if I have A minus B or A plus B times A minus B is equal to A square minus B square, right? So if you look at the bottom, conjugate means the sign is different in between. So we can use difference of 2 square, right? A is 1, so 1 square is 1. I'll just rewrite slowly. What about square root of 5 squared? Square root of 25, right? What square root of 525 equal? 5, right? So 1 minus 5 is 4. Rewrite the top. You can simplify the 8 with the 4, right? 8 goes into 4 2 times, and 1 down here. So we have 2 times quantity of 1 plus square root of 5. I'll take the answer like this. If you want to, you can distribute the 2, so 2 plus 2 root 5. Doesn't matter, I'll take both. They're both correct. Okay. All right, D, again, make sure you remember always multiply the conjugate of the denominator, right? So multiply top and bottom by root m minus root 5 over root m minus root 5. The bottom, you apply difference of 2 square. So that equal to what? Square root of m squared minus square root of 25. Square root of m squared is m. Square root of 25 is 5. Right. Now the top, they are different sign. I'm sorry, they are the same size, so you have to FOIL. There's no other way around. So square root of m times square root of m is square root of m squared. Square root of m times negative square root of 5 is minus square root of 5m. negative root 5 times root m is negative 5m. Negative root 5m, same thing, right? And then negative root 5 times negative root 5 is positive root 25. And we know positive 25 is 5. Right? And square root of m squared is m. What about the middle term? What about these two? They have the same index, same radical. That means under the radicand, same radicand. So we can add the coefficient, right? Remember, coefficient is 1 here. So negative 1 is negative 2. Square root of 5m. Just rewrite the radical part, right? And I don't think you can simplify any further. So leave it like that. And please do not, at this level, do not simplify this with this. And this. They're not the same thing, right? They being married by the sign. Oops, I forgot the plus 5 here. I forgot the plus 5 here. You cannot simplify it like that. Right? You only simplify if they're multiplication. Number 3 is solve radical equations. I believe this is section 8.6. And then make sure you check your answer. Okay. The first one easy. They both radical, and then each of them is being isolated. So all we have to do is square both sides. Use black here. Square both sides so that I have square and square root cancel. So 3u plus 7 equal 5u plus 1. Subtract 3u. Some other people subtract 5u. Just that I don't want my u to have a negative coefficient. Cancel. So I have 7 equal 2u plus 1. Subtract 1. So I have 6 equal 2u. Divide both sides by 2. U equal 3. And then you check. You plug in 3 for u. So let's see. 3 times 3 is 9 plus 7 is 16. So square of 16 is 4. And then 3 times 5 is 15 plus 1 is 6. Also square root of 16, which is 4. Right, so checked. All the exam, I'm not going to ask you to like check it out, like write it out, check it out. If you do, good for you. I would recommend so, because this exam is short. But if you have to put the check mark there in order to receive the credit for check your answer. Okay. If you don't put a check mark there or box your answer, then I just assume that you didn't check, and I'll take a point off. All right. Uh-oh. 3. Something wrong with number 3B. I fixed it. Give me 1 second. Okay, so 3B is supposed to be like this. I fixed it. It just didn't save it on the iPad. Let me rewrite this. Let me rewrite the whole equation. Okay, it's square root of x minus 1 plus 2 equal square root of 2x plus 6. Okay, for this kind of problem, we have 2 radical and then 1 number all by itself, right? So you need to isolate each radical on one side. One side have 1 radical and then square root, which is we did, right? It does have one of the side have its own radical, so we're good. So the next step will be square both sides. Let me use blue, so square both sides like that. The right hand side is easy, that's just 2x plus 6. The left hand side you have to pull it out, right? So let me fold it up here. So I have root x minus 1 plus 2 times root x minus 1 plus 2, and then FOIL it. So I have x minus 1, right? So because square of x minus 1 square is x minus 1. Plus 2 times square root of x minus 1 inner plus 2 times square root of x minus 1 again, and then last plus 4. All right, so simplify. I have, well, x is all by itself, so nothing there. It's just x, right? What about negative 1 and 4? Negative 1 and 4 will be positive 3, right? So plus 3. And then the two guy right here, they have the same index, same radicand, so you just add the coefficient. So plus 4. Come on, plus 4 square root of x minus 1. Again, at this step, you know what to do, right? You isolate everything, move to the right. Everything, you're gonna move everything to the right. Move everything that is not radical. I'm sorry, move everything that's not radical to the right. So subtract x, subtract 3, subtract 3. So gone. I have 4 square root of x minus 1 equal x plus 2. Oh, I wish. Oh, that's a 4. Okay. Good God, I wish it was a 2. All right. Why? It's nothing wrong. We're doing the right. We're doing so far so good. But at the end, I don't want it divisible side by. I don't want it to be fraction. Darn it. Oh, why does it have to be this way? Hang on, let me fix it up a little bit. Oh, let's go ahead and do it. I'm sorry. On the exam will be very nice. Your number will be very nice. So divide both side by 4 because you need to isolate the radical. Right. So I have square root of x minus 1 equal x. I hate it when it's fraction. Give me a second. Why can't it just simplify it nicely? Oh, simplify it nicely, not. You know what? Here. I have an idea. So I'm gonna fix it into an x here. So no. So there's 0. All right. So on the right hand side, let me erase this. On the right hand side, when you subtract x, it's gone both sides. It just leave you with 3, right? 3 is 5. What about we can make it into 7? 7. How about that? Yeah, 7. I'm just trying to make it so the problem it doesn't have fraction. So 7 down here. 7 minus 3 is 4. Divide much better. Divide both side by 4. On the exam will be kind of like this. I don't mean to give you fraction. Divide both side by 4. That's cancel. So you have Square root of x minus 1 equal 1. Now you square both sides. Use black. Square both sides. So on the left hand side, square and square root cancel. So x minus 1 equal 1. Add 1. X equal 2. And let's check. Let's plug in 2 back to the original. 2 minus 1 is 1. Square 1 is 1. 1 plus 2 is 3. Okay, so the left hand side is 3. 2 plus 7 is 9. So square root of 9 is 3. Yes, so it is a solution. You box it and then you put a little check mark here to at least box it. So I know that you check. Okay. If you don't do anything. All right. C again. We isolate one radical for each side and then to square root and then square both sides. So square and square. On the right hand side, that's easy. That's just m plus 8. On the left hand side, you have to FOIL it. Put it right here and move it to the right a little bit so we have more room for foiling. We can rewrite it at let me do it like this because I don't feel like writing m plus 8 all the time. So we have square root of m plus 6 times square root of m plus 6. And then we FOIL it, right? So square root of m times square root of m is square root of m squared, which is m. Square root of m times 6 is 6 square root of m. 6 times square root of m is, again, 6 times square root of m. 6 times 6 is 36. Simplify. M plus 12 square root of m plus 36. And bring this one down. Equal m plus 8. Right. Subtract m both sides. So I have, yeah, 12 square root of m plus 36 equal 8. Subtract 36. Gone. 12 square root of m equal negative 20. 26, right? 26. Divide both sides by 12. Square root of m equal, was it 3? Negative, no, I don't think so. 26 divided by 4 is, no, 26 divided by 2 is 13. 13 over 6. So negative 13 over 6. Then you square it to get rid of the square root. Right. So m equal, negative 13 square is 169. 6 square is 36. And then you plug in your answer back to check, and I believe it's check. All right. All right, D, we need to isolate B. If I give you exponent instead of root, instead of say 4 root of 12x minus 3, I give you exponent, it's the same thing, right? First, I need to isolate my term here, my root term here, right? So add 5 both sides. Gone. So I have 12x minus 3, all of that to the power of 1/4 equal 3. How do I get rid of 1/4? You raise both sides to the 4th power of 4 over 1 over 1. So on the left hand side, 1 over 4, 4 over 1 cancel. So this is 12x minus 3 equal 3 to the 4 is 81. Right. Add 3, so 12x equal 84. Divide both sides by 12. X is 6, 7, 8. Okay, then divided. I don't feel like doing my head. 84 divided by 12, 7. All right, let's check your answer. Plug in 7 for x. So 12 times 7 minus 3. That's 81. 4 root of 81 is 3. 3 minus 5 is -2. Yes. And you can use your calculator. Check. I show you how to do that on the lecture note. Okay, you can go back there and then rewatch the video. All right, E. Label as now we have square root of 5x plus 1 equal -3. 8.6, you don't know anything about imaginary solution yet. So I'm allow you to say none, right? Because there's no square root that give you a negative real number, the real solution, right? So maybe I need to specify my description here. Your answer should be in real answer, not imaginary answer. So square root is a square root on the left equal negative number. That's not a real number. Your answer should be none, not a real number. Or you can solve, go ahead and square both sides. And then when you check it back, it does not equal, then you know that it's not, okay? What about F? F, well, I need to get rid of the cube root. Power of 3 will be get rid of the cube root, right? And you have to do it both sides. So on the left hand side, the cube and the cube root cancel. So just 4y minus 1. On the right hand side, 3 cubed is 27. Add 1, so 4y equal 28. Divide both sides by 4, y equals 7. And I will leave it check. How about G? G is similar to number 1, but instead of square root, it's cube root. But same thing, right? You want to get rid of the cube root, so you just cube both sides. Just cube both sides. So you have cube and cube root cancel. So 5x minus 1 equal x plus 3. Subtract x both sides. I have 4x minus 1 equal 3. Add 1. I have 4x equal 4. Divide both sides by 4. X equal 1. And I also will leave it check. 5 minus 1 is 4. Cube root 4. Yeah, they check. H is very similar to C. I want you to do on your own, okay? I'm gonna pause it here and give you the answer, but I want you to do on your own. And then look it back into the video, all right? All right, after a pause, I solved it. So that's the answer, but I encourage you to do on your own. Number 4, solving quadratic equation. This part I asked you to watch at home. This is 9.1. I asked you to watch at home. The video I pre-record at home. Okay, so 4a, we can take square root both sides. Right, square root both sides. When you take square root, don't forget plus and minus. Remember, over here we square. We don't take square root, we square, right? We do the opposite. We do the inverse. Here we take square root. When you take square root, don't forget add plus and minus on the number side. Right? So on the left hand side, square root of u minus 6 squared, that's just u minus 6. On the right hand side, square root of 64 is 8. So this implies either u minus 6 equal positive 8 or u minus 6 equal negative 8. And then you solve, right? Add 6 both sides, so u equal 14 on the top and u equal negative 2 on the bottom. Right? Makes sense. You should have two solutions because it's quadratic. Right? You may check your answer. It's not required. It's good to check. It's not required, but make sure you check it for the sake of your exam. How's my iPad here is dying. All right. B, we need to isolate the square part, right? So F5, so I have 4 times quantity of x plus 3 square equal 27 plus 5 is 32. Divide both sides by 4. X plus 3 square equal 32 divided by 4 is 8. Now you take square root. Again, don't forget plus and minus. On the left hand side, it's just x plus 3. On the right hand side, well, there's a plus and minus, so this is right here. What is the square of 8? You need to simplify the square of 8. 8 is 4 times 2, right? So 2 square root of 2. Subtract 3 both sides. I have x equal negative 3 plus or minus 2 root 2. You can write it separately. I like to combine them like this when I don't have to simplify more. You can write it as x equal negative 3 plus 2 root 2 or x equal negative 3 minus 2 root 2. Okay, but you can combine like that. C and D. Now, C, if you can see if you can factor the left, this is very similar to one of the problem I did on the video. So if you can factor the left, you see that it's a perfect square. Okay, so let's factor the left. 2 number multiply give you 4 and add to negative 4. Oh, negative 2, negative 2. Well, m minus 2 times m minus 2 is the same thing as m minus 2 squared equal 8. Now we take square root. Don't forget plus and minus. On the left hand side, just m minus 2. On the right hand side, we did that before on problem B. Square root of 8 is 2 root 2. Add 2 both sides. So m equal 2 plus or minus 2 root 2. I hope you're not gonna combine the two together. They not like term. Okay, one is 2 and then times square root of 2. The other one is just 2. It's two different things. Right. Again, we have two solutions, which just makes sense because it's quadratic. D. D a little bit more challenging because I'm asking you to factor the left that the coefficient is not 1. You can do the AC method, but I'm going to do the guess and check here. Okay, I'm going to say 3y, 3y, and then 2 and 2, and I'll check. Because 3y times 3y is 9y squared, and then 2 times 2 is 4. So I got the first and the last cover. I got to check for the middle one. So the middle one is, I want it to be positive 12y. Yes, it is, right? If you check, 2 times 3y is 6y, and then 3y times 2 is also 6y, so 12y total. So it'll be 3y plus 2, all of that square equal 9. Take a square root. On the left hand side, it's just 3y plus 2. On the right hand side is 3. Subtract 2, so 3y equal 1. Divide both side by plus minus, I forgot. Ooh, yep. Plus minus. So let me break it into two cases. So now I have 3y plus 2 equal positive 3, and 3y plus 2 equal negative 3. Okay, you know how to solve the linear. I'm just gonna do it fast. Subtract 2, so that'll be 1. So y equal 1/3 at the top. On the bottom, negative 5/3 bottom. Okay, all right. E. Again, you need to isolate the square, the perfect square. So subtract 10. So I have x minus 4 square equal negative 1. Can us, okay, because you don't know any imaginary solution. You haven't saw a equation that involve imaginary solution yet. So a square on the left and the negative on the right, that does not make sense, right? Because any number when you square, it gives you at least 0, right? So you can say no solution. This is not possible. So your answer is no solution. F, subtract 5. Right, again, you always isolate the square term. So I have 2r squared equal 25. Divide both side by 2. I got r squared equal 25 over 2. Oh, so square root. Yeah, 25 over 2. Sorry. And then now you take square root. I got r equal plus minus. So square root of 25 is 5. So square root of 2 is square root of 2. But now we know how to rationalize the denominator. I do not want my answer to be in radical in the denominator, right? So how do I rationalize that? Multiply top and bottom by root 2, right? So what do you have? R equal the plus and minus 5 times root 2, and the bottom is root 2 times root 2 is root 4, which is 2. Please try on your own first before you actually listen to my solution. I think that helps. Number 5, simplify the expression in terms of I. So now we on 8 point, this is 8.8. 8.8. Oh, I wonder because 9.1, this is 9.1. 8.8, we already did 8.8. Then you're not supposed to say no solution anymore. No. Yeah, you're not supposed to say no solution anymore. Let me go back. I'm sorry. Square both sides. So on the left hand side, it's just x minus 4. On the right hand side, what is the square root of negative 1? Excuse me. That's just I, right? And now you add 4 both sides. So the solution will be x equal 4 plus or minus I, right? Right, that's this is 9.1. So it's after 8.8, you cannot say none anymore. Number 5, write each expression in I and simplify if possible. All right, square root of negative 16 is equal to, if I was you, I would break it up into square root of negative 1 times square root of 16. Well, square root of negative 1 is I. Square root of 16 is 4. So 4I. You know what? I'm going to write it in terms of A plus BI. So it's going to be 0 plus 4I. Okay. On the exam, I'll specify that. Same thing would be, I'm going to rewrite it at square root of negative 1 times square root of 15. Square root of negative 1 is I. Square root of 15 is square root of 15. I don't think you can break 15 into two numbers. One of them is perfect square root. Or 0 plus square root of 15I. Okay, now number 6 is similar to 5, but instead of doing things separately, you add them or you subtract them. By the way, this is supposed to be subtract, I believe. Yeah. Okay. Square root of negative 75. We need to break it apart first. Right? So first of all, let's do this. First of all is square root of 75 and then I, right? Because we factor out the negative 1. And then I square root of 48. I don't want to say factor. It's not factor really, but all right. You need to break it up square root of 75. So let's see, 75 divided by 5. 7 divided by 5 is 1. 25, 15. I'm sorry, 25 divided by 5. Yeah, 15. And then 5 times 3. So 25 times 3. Which is 25 is square root of 25 is 5, right? So 5I root 3. What about 48? Down here, 48 is divided by 2, 4 divided by 2. I don't feel like writing it down. You can use your calculator. 48 divided by 2, 24, 16. So 48 divided by 16 is 3. So 16 times 3. So square root of 16 is 4. So that's 4I. And square root of 3 is square root of 3. Are they like term? Yes, right? They both root 3 here. All you have to do is what? Add in the coefficient, right? So 5I plus 4I, that's 7I. Root 3, or better yet, 0 plus 7 root 3 times I. Make sure you put the I not under the square root. Right. B, I want you to do on your own, and then come back and look at my solution. Okay, C, adding. Well, you add like term to like term, right? So 6 plus 3 is, and then you know what, if I was you, I'll do one more step here. Well, 6 plus 3 is 9. 2I minus 4I is negative 2I. That's easy. Reason being is because we don't have to take care of the negative. Now, D, I would recommend you FOIL it first, because in front of negative there, like negative 1, you need to FOIL that negative 1 into each of those. term. Right? So negative 2 plus 5i plus 5 minus 6i. And now you can combine like term. Right? Negative 2 plus 5 is 3. 5i minus 6i is minus 1i, which is 5. Multiply complex number and write your answer in form a plus bi. The first one we distribute. So we have negative 6i plus 2i squared. Well, I squared is negative 1. So it'll be negative 2, right? Or better yet, negative 2 minus 6i. Because they want to inform a plus bi. B, you have to FOIL it because there's two binomials. So first, negative 3 times negative 2 is positive 6. Negative 3 times negative 7i is positive 27i. 3 times negative 2 is minus 6i. Last 3i times negative 7i is negative 21i squared. Do one step at a time. Okay, don't try to shovel several steps in your head. You make mistake. Well, I squared is negative 1, so that's become, this whole thing become positive 21, right? 6 plus 21 is 27. And then you combine like term, 27i minus 6i is 21i. And that will be your final answer. C, we're going to expand it and then FOIL it. So 3 plus 4i times 3 plus 4i. FOIL it. 3 times 3 is 9. 3 times 4i is 12i. 4i times 3 also 12i. 4i times 4i is 16i squared. 16i squared become negative 16. Remember what I say? As soon as you see I squared, you change the size of that number and then get rid of I squared. Right? 9 minus 16 is negative 7. 12i plus 12i is 24i. D, I will recommend you go ahead and I would recommend you simplify each of these first. So what is the simplification of the root negative 9? Well, it's going to be I times root 9, right? I times the square root of 9. Well, square root of 9 is 3, so 3i. What about square root of negative 10? Negative 100, I'm sorry. So this is one. The other one is I times square root of 100, which is I times 10, or 10i. We write 10i. 3i times 10i is 30i squared, which is negative 30. Or better yet, negative 30 plus 0i. The reason that we have to simplify each of these first, I'll tell you why. Because what happened if you multiply them together? What happened if somebody do something like this? Don't write this down because it's wrong. They combine those two, like, oh, they have the same index, I can combine them. Nothing wrong with that. But the thing is that because they already a complex number in the beginning, then you have to change it into a complex form first, right? So this one, if you combine it into under one root, I have negative 9 times negative 100 will be negative 900, positive 900, which is positive 30, right? Which is not the answer that we have. Because these are complex number, you have to make it into a complex form first before you do the operation. Okay. Divide complex numbers. Now, divide complex number is kind of similar to rationalize the denominator. So when up here, when we rationalize the denominator, we don't want radical in the denominator, right? Here, divide complex number, we don't want I in the denominator. So what do? We multiply top and bottom by the conjugate of the denominator, right? See, very similar. So for A, I'm going to multiply top and bottom by 3 plus 4i over 3 plus 4i. In the bottom is the difference of 2 square, right? A minus b times a plus b. A here is 3, so a square is 9 minus b square. What's b square? 4i quantity square, which is 16i square. Right? Make sure you square the 4 as well. Well, 16i squared, that is positive 16. Right? Let's become positive 16. 9 plus 16 is 25. So we've done the denominator. Now the numerator, we have to FOIL it. There's no other way. So 2 times 3 is 6. 2 times 4i is 8i. I times 3 is 3i. And I times 4i is 4i squared. We know 4i squared is minus 4. Becomes minus 4. 6 minus 4 is 2. And then combine the 2. 8i and 3i, that's 11i. And please don't stop right here. You need to write it in a plus bi form. So that means you have to split them apart, the real part and the imaginary part, remember? So 2 over 25 plus 11 over 25 times I. I might take you a point off, but you don't go from this to this. You might. But please just follow the instruction. Okay, now B. B is, it's just I, it's just 2i in the bottom, or just I, right? It's not like A here where we can multiply the conjugate. It is a conjugate. Now remember, if I just have I, don't write this down, I can rewrite it as I plus 0, right? So what is the conjugate of I plus 0? Well, I minus 0, which is also I, right? So the conjugate of the denominator here in part B will be just I. So multiply both top and bottom by I, which just makes sense, right? Because I times I is going to be I squared on the bottom. So 2i squared, which is negative 2. On the top, you distribute. I times negative 3 will be negative 3i. I times negative 5i will be negative 5i squared. And now negative 5i squared becomes positive. Right. So 5 minus 3i. And again, split them apart. Negative 5 over 2 plus 3 half I. The power of I, remember we're going to take the power and divide it by 2, or if it even number, then go ahead and divide it by 2. So inside the parenthesis, I'm going to have I squared, and outside, if you take 162 divided by 2 will be what? 16 divided by 2 is 8. 2 divided by 2 is 81, right? We know the I squared is negative 1 to the 81 power. Well, a negative 1 to the odd power is going to be odd. It's going to be negative, right? It's going to be negative. So the final answer is negative 1. What about B? 255 does not divide into 2 evenly, so we have to split it apart. I'm going to split into I to the 254 times I to the first. To the first. So what number here? Well, what number multiplied 2 give you back 254, right? So all you have to do is take 254 divided by 2 in your calculator, right? So 2 divided by 2 is 1, 5 divided by 2 is 2, 127. I squared is negative 1 to the 127 power times I. Negative 1 to the odd power is negative 1 times I, which is negative I. These are easy problem. Please don't mess it up. My suggestion is that please do the practice exam on your own first, and then take a look at my solution. If you don't understand, watch my video, okay? And then do it again. Do it all over again without watching me or look at the solution. Okay, repetition is a key. Now for your I said that I'm gonna have some sort of extra credit for your exam too. So like I said last time, if your exam 3 is better than the score of the exam 2, then I'm gonna take the average of exam 2 and exam 3, and that will be your new score for your exam 2. But I'm gonna skip the original score for your exam 3. Okay, does that make sense? All right. All right, good luck. Study hard, but don't not don't stress out too much. I'll see you Monday.